Hello, everyone. We're going to work on our factoring review today. So this is a review of topics covered back in Algebra 1 and Algebra 2 for factoring, and they are skills that we will use again when we progress through some of the future units, including analytic trig and a couple of other ones. Okay, so most of this stuff should be familiar, though there are some points that you may have forgotten. Try your best to follow along and see if you can work some of the examples independently as well. Let's start with this first group. The instructions say factor each completely, and that essentially just means using whatever technique you want, break this down until it's fully factored out. In this case, all we can do is take out a GCF, which stands for greatest common factor. It is the largest value that we can divide out from both of the pieces that we see here. Okay, so 2v squared minus 12v. I'm going to take out a 2 and a v from these. So 2v squared, when I divide by 2v, I'm left with just a single v. Now 12, when I divide by 2, is going to leave me with the minus 6, and that v is going to be taken away because I have divided it out. Okay. Similarly, if we look at number 2, what would our GCF be in this case? What can we take out from there? It would be 5n, and we would be left with just n plus 1. Now note that there is a 1 left there. When I divide 5n by 5n, I'm left with 1. Do not forget that 1. That is very important. Okay? All right. So the first group is pretty straightforward. Taking out GCFs, you guys have been doing that since middle school, but let's take a look at factoring some quadratics. Okay, so a quadratic is something that has a squared term as its highest power. And basically, this is a full quadratic. It does not have any missing terms. So how can we factor this? I'm going to use a technique we refer to as grouping. And this technique is super powerful and useful because it applies to a lot of scenarios. There are various ways people use to factor quadratics, including things like box method, slide and divide, and a whole bunch of other ones. But this is a technique that will always get you to the final answer, even if it is not the fastest way. Okay, so first I'm going to take my first and last number, and I would multiply them together. So n squared, that's just like a 1 in the front here. So if I break down negative 30, what numbers can I use for multiplying to negative 30 that might add up to 7? Okay. Hopefully you've come to the conclusion that it is 10 and negative 3, because when I add those two together, they give me 7. Okay. So what we do, we split our middle term up. It's going to be 10n and minus 3n. Okay. And I'm bringing the rest of this problem down. So there's n squared, and there is minus 30. Okay, so all I've done is I took that 7n in the middle and I split it up into the two numbers that we said would multiply to make that 30. Now from this point, this is where the grouping part kicks in. Okay, so we're going to take our first and last two terms and put them in groups. So I use a parentheses to group them up. And then we're going to take GCFs out from each of these. So if I take the GCF out from this first parentheses, all I can do is take out an n, and I'm left with n plus 10. Okay, and in the second group, I'm going to try and get this parentheses to match this n plus 10. So I'm actually going to divide by negative 3. Now, if there's a negative on this first term, I always like to take that out. And this is going to be n, negative 30 divided by negative 3 is positive 10 again. Okay, and let's combine our two pieces together here. So these loose pieces are going to form a single parentheses. And then the other parentheses that is a matching parentheses already, you see these two are matching, those two will form a single copy of that parentheses. Okay, and this piece that I've written in blue is the fully factored answer here. Okay, and so you can see grouping involves grouping the first two and the last two terms after we split that middle term up, and then taking out GCFs. Once you do, you should get two of these factors to be matching. They should be in these parentheses matching. And then you can combine the other two pieces to make that final answer. Okay, so that is factoring by grouping. Okay, and we're going to apply that again in number 5. So you may notice number 5 seems a little different. There's some kind of issue here. Because we said we were factoring quadratics, but suddenly this is a cubic. It's got a to the third power. Okay. So what can we do about this? Let's see. Let's start by actually taking out a GCF from this. So I noticed that there's an A in all of these, and I'm going to take out 4A from both of these, and we're going to have A squared plus 4A minus 12. And suddenly, like, this is a proper quadratic that I can factor. And so we'll follow the same steps that we did earlier to factor this quadratic that's in the parentheses, right? So again, this is just a 1 in the front. So 1 times negative 12 makes negative 12. What can we split that up into to add up to 4? That should be 6 and negative 2. Okay, so again, I'm going to take this and I'm going to split my middle term up. Okay, so I'm going to keep this a squared plus 6a for this 6 minus 2a and minus 12. And then let's use grouping to finish this problem off. So group the first two, group the last two. From the first group, I'm going to take out an a, and I'm going to be left with a plus 6. Okay. From the second group, remember this negative's in the front, so I'm going to pull out negative 2, not just 2. And I'm going to get a plus 6. So remember, when you take out the negative, it's flipping that sign. Okay? So let's combine this to make our final answer. A and minus 2 will make a single parentheses. A plus 6 is my other parentheses. And don't forget this 4a that was here. Bring that down. It's still hanging out in the front here, okay? And this ends up being my final answer. Okay, so if you take out a GCF, just make sure that you need to bring it down in the front all the way at the end as well. And this is essentially factoring by grouping. And some of you who have used box method or the X method, those are the same technique. They're just set up a little bit differently, but the process is roughly the same thing. Let's solve one more problem with grouping. Number 7 is a little bit interesting. Okay, so let's start the same way we started before. Let's take out a GCF. What you'll notice is our GCF in this case is going to be 2. So I can divide all of these by 2, and we'll get something like this. 2 times 3n squared plus 23n minus 8. But you'll notice this time there's something interesting happening here. There's this 3 still hanging out here. That's something new. But it doesn't really change the dynamics of grouping, which is the good thing about this method. Okay, so again, let's follow the same steps. 3 times negative 8. Remember, multiply that first and last. And we get negative 24. And the numbers will add up to that 23 that's in the middle. So I'm just going to use 24 and 1. And my 1 is, of course, going to be the negative in this case. So I'm going to split my 23 up into 24n minus 1n. And we'll keep that remaining parts of our problem with us here. And so now we're ready to group. Let's group these up. And let's see what we get. So what can I take out from this first parentheses? 3n squared plus 24n. It's not just n this time. I can actually take out 3 from here as well. So n plus 8. And from this one, can't really take anything out, so I'm going to take out just minus 1. Divide everything by negative 1, and we get n plus 8. Notice again, those two parentheses should match. That's a double check for making sure that you've completed all the steps correctly up till now. Okay? Remember, if you see the negative in the front, that's a sign to take it out when you pull it out from the parentheses. Okay? Let's put this together. We've got 3n minus 1, n plus 8. And don't forget that 2. He was there. Let's bring him down as well. Okay? And there's my final answer. 2 times 3n minus 1 times n plus 8. And that's fully factored. Okay? So that is factoring by grouping. Take a second, guys. I want you to try number 9 the same way and pause this video and I'll show you the answer after you finish. Okay, so here is your answer for number 9. You should have multiplied 2 and negative 24 to get negative 48, and you would have broken that down into negative 16 and 3. From there, set up your grouping, take out the GCFs, and you should be left with 2n plus 3 and n minus 8. Now, commonly people ask, does it matter what order you put your factors in? What if n minus 8 comes first? That doesn't matter at all. What happens if you flip-flop the 3 and the 16? As long as you keep the signs correct, you'll still get the same answers. Let's continue our factoring review. So in these next two sections, we're going to talk about a couple of special cases for factoring. And by special cases, I just mean they follow kind of a pre-existing pattern that we can reuse multiple times, okay? So our first group says factoring using the difference of two squares, okay? So the difference of two squares, sometimes people abbreviate this as dots, D-O-T-S, okay, follows a very simple formula, okay? And here it is. If you have two squares that are being subtracted, a squared minus b squared, the factored form of this is a plus b and a minus b. And again, the order of those two doesn't really matter. You could put a minus b first and a plus b second. Okay, so if we can identify that the two pieces being subtracted are squares, we can use this formula. Let's take a look over here. So I see 9n squared minus 16. Both of these numbers look like squares to me, so I'm going to rewrite them as proper squares. So 9n squared comes from 3n being squared. And 16 is going to be 4 squared. And so basically, I can identify that these two fit in the spots for my a and b. I would call a as being 3n and b as being 4. So this essentially just breaks down into 3n plus 4 and 3n minus 4. So this is a super common and popular factoring pattern, so make sure that you have this committed to memory, okay? Remember, a squared minus b squared equals a plus b times a minus b. Now, notice this only works if the two numbers are being subtracted. So if you ever see squares that are being added, that's a no-no. It's not going to work there, okay? See if you can do number 13, and then I will show you the answer for it. So in number 13, you'll notice, hey, they just have 9x squared, which can be written as 3x to the second power, and 16y, which is 4y squared, okay? And this will break down finally into 3x plus 4y and 3x minus 4y, okay? So again, pretty straightforward. As long as you identify what numbers are being squared, you can very easily just fill in this formula. Okay, how about number 15 though? Number 15 might seem a little different, okay? U to the fourth minus 4v to the fourth. Now, what if we rewrite these as squares? This could be u squared to the second power minus 2v squared to the second power. So again, let's follow our formula. Remember, a squared minus b squared is equal to a plus b times a minus b. So in this case, we've got u squared in our a spot. So here's u squared plus 2v squared and u squared minus 2v squared. Now, one thing to be on the lookout for with these fourth powers, right? We got to make sure that it could factor again if we had gotten another perfect square. So in this case, it does not, but it's just something to be on the lookout for, right? If these were perfect squares, they might factor again using the same rule that we have been using. Okay, so just something to be wary of when you do a fourth power, that sometimes they factor twice, and you have to kind of be careful of that. Okay, now onto this last section. We are talking now about factoring using the sum and difference of cubes. Okay, so two things to note here. So first, this operates on both sums and differences. Okay, so we can actually have cubes added together and those will still work. Unlike squares, squares only worked when they were subtracted. Okay, so first, let's take a look at the formula for this and then we'll try to apply it. The formula goes like this: a cubed plus or minus b cubed equals a plus or minus b, a squared minus plus ab, and plus b squared. Okay, now this formula is a lot to take in at first glance, but let's make some mental notes here so that we can remember this. Okay, the first thing that we can note here are the signs that are being used here. So whatever sign you have in this problem in your original, this first sign will be the same. Okay, and the second one, I was really careful to write them upside down. I said instead of plus minus, I wrote minus plus, because this sign is the opposite of the first sign. Okay, and then the last one is only a plus. Last piece is always positive. And this forms a really handy acronym that we can use to remember this rule. It goes SOAP, which spells soap. Okay, so that's one handy rule to help you remember this formula. The other thing is, most people remember that the first group is just AB, but the second group is kind of hard to remember, that second parentheses. And so just think, you start with a squared, and each time you go to the next term, take that exponent down. So you go from a squared to a single a, and then to no a's at the end. And b is the opposite. B just counts upwards. So it goes no b's, then one b, and then two b's as your final one. Okay. So it can be a little bit tricky to apply and fill all of this in. Okay. So make sure that you have this written down, and then let's go try to apply it to a problem. Okay, so looking at number 17 here, again, we need to first identify these as being cubes. Once we understand that these numbers are cubes, it's a lot easier to fill in the formula. So let's start with this, 64x to the third. That's very simply 4 cubed, which makes 64. And 125 is 5 cubed. So I'm going to use 4x and 5 as my a and b in this problem. And I'll fill them into my formula and then simplify my final result. Okay. So if you're not sure about cubes, just remember you can always check with a calculator what cubed makes a certain number. So please do take advantage of that. Don't mess up that number part. Okay. Let's check it out. So we're starting with a minus here. Okay. So my first parentheses is going to be minus. It's going to be 4x minus 5. That's my a minus b section. Okay. And then I've got this 4x squared, a squared. This time my sign is the opposite, so plus, and then I've got 4x times 5, and then always positive, my last term, 5 squared. Now, this is the very rough version of the formula that I'm writing out, and then we'll write our clean version now as our final solution, okay? So the first parentheses is good, 4x minus 5. But the second bit, what is 4x squared? That's going to make 16x squared. And then 4 times 5, let's go ahead and multiply those. We get 20x. And 5 squared is 25. So I took a second to write it out unsimplified to make sure that I didn't make any mistakes getting my final answer. And this here in blue will be my final answer. Let's similarly apply this to solving number 19. Okay. And you'll notice they tried to pull a switcheroo on us. They said, hey, I'm going to put the non-variable part first. And that doesn't really change how we approach the problem. We can still solve it the same way. But they threw another curveball at us too. 128 and 54 are not actually cubes. So how am I supposed to use the difference of cubes here? Well, they in fact include a GCF. So let's take out our GCF first. Both of these numbers will actually divide by 2. And I get something like this, 64 minus 27x to the third power. And that piece that I just came up with is in fact perfect cubes. This is 4 cubed minus 3x cubed. And now I'm going to apply the formula the same way to this problem, okay? So here is the problem worked out. So I've got 4 minus 3x, then 4 squared in the first spot, plus, remember the opposite sign, 4 times 3x. And I use parentheses when plugging stuff in. It will keep us from making any mistakes. And 3x squared in our final spot. Okay, and so what does our final simplified answer look like? We got 4 minus 3x, 16 plus 12x plus 9x squared. And don't forget about that 2 we took out. He's been hanging out this whole time. So there we go. There's our 2 in the front as well. Okay, and this right here, this last line will be our final answer in this case. Okay. If you're feeling confident, go ahead, pause the video, and try out number 21. It's going to follow the same rules. Just watch out. This time the signs are a little bit different, but you can still follow through with it using the same exact rules we have been. Hopefully you caught on that there is a GCF here as well. And so we can actually take out 4 from both of these numbers. We get x cubed plus 125y cubed. Okay, and so this one rewrites pretty easily as cubes, x cubed and 5y cubed. So let's apply our formula to this piece, and don't forget to keep bringing this 4 down with us. So here we go, x plus 5y, x squared, minus, remember the sign is always the opposite, we've got x times 5y, and again, I'm just using parentheses to make sure I don't make any mistakes, plus 5y squared. Last one's always positive. So what's my simplified answer going to look like? Not forgetting about our 4. 4x plus 5y, x squared minus 5xy plus 25y squared. And there you go. There's your final factored form. Okay. So a couple of things to note. Make sure you follow that SOAP rule for signs with this. And just as a note, the portion that you factored out, this trinomial at the end, that will not factor further. Okay, so this last bit that you have that long piece in the parentheses, that should not factor any further unless you are dealing with some really strange or higher order stuff. Okay, so in general, that piece does not factor. Okay, so hopefully this review was helpful to you guys. Good luck and happy studying.